Okay, this is the beginning of Lecture 28, Lecture 28, Part 1. In this lecture, we're going to look a little bit at how we quantify energy changes associated with chemical changes, and sometimes we call this thermochemistry. So we're going to calculate the amount of heat energy produced or needed by a chemical change. And we have ways of experimentally determining the heat change, and we also have ways of theoretically determining the heat change. So we're going to take a look at both of those in this lecture. Okay, well, it's important to quantify energy because the economy of the world, is very, very dependent on energy, having enough energy to supply the demand and to keep trade flowing and the lights on and whatnot. And so if you are going to, for example, build a ship to transport your goods across an ocean, you ought to know how much energy you can get out of a certain amount of fuel. And you need to be able to calculate how far that boat's going to travel, how much energy it's going to take to push it across the ocean, and therefore how big your fuel tank should be. Just basic ideas like that we can do because we understand how to quantify energy. Same is true with a bus. When you design a bus, how big should the fuel tank be? How many times should you have to stop for gas? For a power plant, coal-fired power plant, you're going to want to know how much coal you need to deliver to your plant every day to supply the amount of electricity you need for the number of homes or businesses that are using your energy. So there's lots of legitimate reasons why we need to be able to quantify energy and why people can quantify energy. So you've already calculated the amount of heat energy produced by a certain amount of fuel. For example, the amount of heat energy released when 1 gram of methane is burned is about 50 kilojoules. We've seen that already. And what that means is that, for 50 kilojoules of heat energy is released per every 1 gram of methane that is burned. So you can write a little ratio like that to show the relationship between the amount of energy released, in this case 50 kilojoules of heat energy, for every 1 gram of methane that is combusted. All right, so because we have these types of relationships, this would be considered sort of a thermochemical quantity that when I have a chemical change with methane, the kind of chemical change we call combustion, we're going to give off 50 kilojoules. And because we have these kinds of ratios, we can answer questions like how much heat energy would be released if 1 kilogram of methane were burned. Okay, so if the rate is 50 kilojoules per every 1 gram, you could very easily, and you've already practiced this, calculate the amount of heat energy given off when you burn 1 kilogram. So you would just take your relationship, 50 kilojoules per 1 gram of methane, and 1 kilogram of methane, of course, is the same as 1,000 grams. So times 1,000 grams of methane, and you would very easily calculate that you need, or that you would produce 50,000 kilojoules of heat energy upon combusting 1,000 grams of methane. Okay, so we have these little relationships. We can do these simple little mathematical manipulations to predict the amount of heat energy given off given a certain amount of fuel. But you should be asking yourself at this point, where did that number 50 kilojoules come from? How did we know that 50 kilojoules of heat energy were given off when you burned that 1 gram of methane? Well, as it turns out, you can calculate this heat given off in a chemical change using a device called a calorimeter. And you should have already seen how that works by doing a POGL exercise, or your teacher may have even had you do a lab using a calorimeter. So that would be an experimentally determined value. Okay, we do an experiment, we burn a certain amount, we can calculate the amount of heat energy is given off, so we can experimentally determine these types of relationships, but we can also theoretically predict, theoretically, I think I spelled that right, predict these types of numbers as well. So today we're going to look again at how one would experimentally determine this type of a relationship, how much heat energy is given off, and then we're going to also take a look in part 2 about how the theory, we can theoretically predict and how close those values are between experimentally and theoretically, and what's actually going on in a chemical change to cause this heat energy to be given off. Okay,